So now let's move into the training part. Okay, so for now I will be showing you the first of all the detection of some objects on the video as well as on the image using a YOLO model. Okay, so YOLO, as you know that you know all the architecture of YOLO and other thing. Okay, so so what tools I am using today? So I will be using the Ultralytics. Okay, so let me show you. So Ultralytics is basically a repository, right, which contain all the tools and requirements, and from this, like, you can also, it is very easy for you as well, right, so that you can actually like try to load the YOLO model very easily. Another thing, okay, you can do so many things, so I will show you one by one. So for now, if you just wanted to go to the Ultralytics website, so you will see that they are actually doing so many pretty amazing things when it comes to the computer vision. Okay, the object detection part, the surveillance part, the pose estimation part, the segmentation part. Okay, and then many different activities as well. If you go to docs Ultralytics, as I told you, always follow the docs, right? So if you just go to Ultralytics docs, you will see there are so many, right? So like then they have already like segregated everything, that how to basically train the model, how to do classification, how to do training, validation, predict, how to export the model, how to track the image. I will cover everything. Okay, so for now, if you really wanted to like go YOLO GitHub, right, so this you will find out the Ultralytics YOLO, and from here I will be showing you that how to do the object detection part, right? Now before that, I really wanted to show you that whatever the things that I'm doing in today's lecture, okay, so I am actually like taking the already pre-trained YOLO model. Okay, I'm not training by myself. Okay, the YOLO model is basically by default pre-trained on the 80 class data. When I say 80 class data, so it is actually, let me show you, COCO data set, right? See, so COCO dataset is like basically a huge bundle of dataset which contain like a lot of image, okay, on which the YOLO model is basically trained. Okay, if you wanted to see the class, so see these many classes on which the YOLO model, which I will be doing this for detecting the object in today's lecture. So that is basically trained on these 80 classes. Okay, now I will later show you that how can you basically like train the pre-trained YOLO model on your own use case, right? So let's say that if you wanted to detect some object which is not, which like your by default YOLO model has not been trained on, okay, and you wanted to detect the object on your data set as well. So usually Ultralytics also provide you the training documentation as well, that how do you basically like train your YOLO model on your use cases, on your business understanding and other thing as well, right? So for now, I will be using the YOLO pre-trained architecture, which has been trained on this 80 class dataset. You can see that it is like traffic light, bench, birds. So normally, whatever the things we normally usually see in day-to-day lives, so most of the object has been covered in this dataset. Okay, and so yeah, let me just go to the documentation part. So these are basically documentation, right, where I will be using the detect. So I will be showing you that how to basically do the object detection part, and then later we will cover up all those different applications of the object detection through Ultralytics by importing the YOLO model from the Ultralytics library. And later I will show you the RoboFlow as well. Okay, the RoboFlow is also one of those so one of those like a tool where you can actually like try to label your image, like do the detection, do the object counting, and do any like so many other things. Okay, so Ultralytics and RoboFlow. Okay, so we will be like hopping into these two things, so that we will be primarily sticking these two tools in order to do the object detection for our use case. Okay, so let me do the object detection part. So let me just open any IDE. Let me create one new one. So this I'm actually like creating a new one, right? So let me open one project. So this must be present somewhere here. Okay, so I'm nothing but I have just like created one separate repo or a separate folder just to do these kind of experiment. Okay, so yeah, let me increase it first. Okay, so now we will be dealing with, first of all, let me create one, the environment. Okay, so yeah, right, so first of all I will be creating one environment. So environment is what, where all our necessary packages should be installed. Okay, so first of all we need to create one Python environment. So for that I will be using Python. Let's say first of all which version it is I need to check. So Python 3 hyphen version I need to check, right? So I'll be using this Python 3.13 version. Okay, and let me just create an environment. So I have already created, I am showing you the command that how can actually like create. So this is the command where like you can actually create an environment, and the one environment will be getting created here. Okay, so it contains all those necessary libraries and packages which you don't need to install explicitly, because these things are already created in the environment class. Okay, so after this command you just need to activate your environment. So let's say for activating the environment, you have a source, then give it the environment name, then go to bin and then activate. Okay, so this environment has been activated and you are good to go. Now before like creating the environment, you need to create a requirement.txt file. Okay, so what is requirement.txt file? So requirement.txt file is basically containing all those requirement which I will be needing it like into the projects. Okay, so like before making this project, first of all, the number one step is to create an environment. Number two step is to create and collect all the necessary packages and requirement which is basically in future you may need, right, in order to import some library in the projects or extra dependencies, right? So you will be putting all these things into a one physical file .txt file into the requirement.txt, so that I will be using these things like to like do my things, right? So I don't need this one, I need this, and I need this, right? So if I just save it, and I need Ultralytics as well, right? So matplotlib I need, yes I need, I don't need tqdm. So Python multipart I don't need, below I need request, I need OpenCV I need, and I need Ultralytics, right? That's it. So pip install -r requirement.txt. Okay, so all my requirement is getting installed here. Okay, installed where? Installed in my environment. Okay, because I will be working in this environment. Now so I have like divided this format into, first of all I will go and I will actually do the object detection on image. Okay, I will show you that how to do the object detection, how to detect any object on set of image. Then we will go by doing the object detection on video or a live camera. Then I will show you the object detection on how to do the object detection on very edge device. So physically I will take one edge devices, let's say Raspberry or Halo Accelerator or Jetson or any edge devices possible for now. So I will show you that how to basically like try to do the object detection on the edge devices and install it and like make it on-prem working in your own system, or how to deploy it. So I will tell you each and everything step by step. Okay, so let's first like dive into doing the object detection part. So I've already created one testing file. Okay, so that you just need to sit and watch and clear your concept. Of course you can do it by like you can parallelly start doing, following my lectures, you can actually like parallelly start doing by yourself, like, but I want you to like see this, visualize the concept, and then like look into this and then do it. Okay, and this in this way like you will be learning more in a very matured way, right? So what I will be doing is that first of all I will be importing the YOLO model as usual, right? So from this I will be actually importing this YOLO model. So let me like select one Python environment. Okay, now let me install it first. Okay, now let me install this YOLO model, right? So this is like the model is equals to YOLO. So from this I have just imported the YOLO. So inside this YOLO I will be using different variants of YOLO. So your YOLO 8, YOLO V8, there are other variants of YOLO. Let me show you that variants as well, right? So let me just go and show it to you. If you wanted to see the variants, so there is actually a benchmarking as well. YOLO version benchmarking. See, so there are many different versions of YOLO. Okay, and like currently we are actually using the YOLO 11 version. Okay, so you can actually like try to use different YOLO versions. So for each version you will be having the set of model. So some will be like the very small model, some will be the model which having a medium size, some model will be having a large size depending upon your system requirement. So I am using the YOLO V11 model. Okay, now let me go to the code. So I'm actually supposed to use the YOLO V11 model. So all these things you will get into the Ultralytics documentation. I will share or pin the documentation and other file below so that you can actually try it by your own self, right? So let me just install the model. So this is what my model is getting installed over here. Okay, you will see that now this is my local model. Okay, so now I don't need any dependencies to like install and looking at the model and calling it as an API, because these models are already like present over here. So YOLO v11.pt. okay, pt is basically pre-trained model. Okay, so this model has been used. So let me just try to predict. Okay, so let's say that this is my one image. Okay, this is the image of a bus. So let's say this is my image, looks like. So the earlier image which I already showed you in the image pre-processing part, so this is the image. Okay, and I wanted to like try to do the image detection part over here. Okay, so let me just cross it over here. Right, so now it is what it is doing, because I have already imported the YOLO pre-trained model, which is actually trained on lot of different 80 classes, right? So out of these 80 classes, whatever the model will see, they will try to detect. Okay, so let me show you that what the model is actually detected. So if I just try to like do the results, right, if I just try to do the results, right, so I am getting these kind of a detection. Now you may be asking that what is it? Okay, so first of all, it is actually the result is actually, first let me just try to print the type of result. Okay, so the type of result, right? So what is basically the type of results? This one, if I just go and write here, so it is basically a type of list. Okay, it is basically a type of list. Now what does this result contain? Okay, what does the result contain? So result is containing, first of all, it containing the list of bounding boxes, it containing the key points. Okay, mask, the names, which means the name is going to contain all those 80 classes, and all those out of all these 80 classes, like up to 0 to 79, so out of all these 80 classes, each will be having its own class ID. Okay, now from our given image, like from our this input image, so it will try to match that which ID is having a more confidence score. Okay, so let's say that whichever is having a more confidence score, so it will try to detect that object and try to plot the bounding box over it. Okay, so this is my results looks like. Okay, now let's say that if I also try to deep dive into the results, now what it should be. So let me just see that, because it is already a list, right? So I wanted to see what is actually present inside the result, right? So let's say that in result, so what I wanted to see is that I wanted to see the bounding boxes, that how many like bounding boxes is actually plotted. Okay, so let's say boxes, if I just plot. Okay, and let me just use it, right? So let me just else print it, right? Boxes. Okay, so what you will see from here, you will, before that let me print the like the length of boxes. Okay, let me print the length of boxes. So you will see that the length of boxes is around 5. Okay, let me just write here so that you will understand. So what it is that, so it is completely detected the 5 object. Okay, so now whatever my YOLO pre-trained model is based on the given input image, so it has actually detected the 5 object, and this is basically the bounding box of that object. Okay, this is like the bounding box of the first object, this is like the bounding box of the second object, third object. If you wanted to print the bounding box, let's say in a pixelated format, so you can actually try X, Y, W, H, which means the xy, which means like this is basically the center, like the center coordinate, so center of x and center of y, and then this is basically the width and the height. Okay, similarly let's say, so this is, let's say that out of this is like the one image frame, and this is the bounding box I have. Okay, so for this bounding box, let's say the middle part is basically your x and y, which means your center of x and center of y. Okay, and then this is basically your width, and this is basically your height. I hope you get it, right? So if I just wanted to print this, right, so I will be getting this thing, right? See, now I'm getting much more in a clear fashion. Okay, so I will be getting the first detected object, and this is basically the center of x and center of y, and this is basically the width and the height. Similarly, the second detected object, the third detected object, the fourth one, and the fifth one. Okay, and let's say that if you really wanted to like plot this, right, so plot this detection over the image, right? So how will I basically do that thing? So again, I will go each detection and I am going to plot it, right? So let's say that for result, right? So let's say for result, in results, right? So I am going to plot the result, right? So let's say that I am going to plot the, so let's say that I will be result dot, I'm going to use the plot method, right? And let's say that, let me save it into the plotted image, right? Let me save into the plotted image. So if I just try to run this, right? So my image is like whatever my input image is, right? So all the detected object has been plotted on this by using just dot plot. So dot plot is basically like a method, okay, which I'm actually calling it inside this result class, so that I will get my plotted image. So if I just see my plotted images look something like this, right? Now I have already like told you in my image processing section, right, that if you really wanted to like, because these things are already in the pixelated format, right, and if you wanted to like plot it over the image, then what should you call? You call the pillow library, right? So let's say that real image, if you really wanted to find out the, let's say the real image, right? So this is my real image looks like with the plotted one, right? See, this is my plotting looks like. Okay, let me just try to reduce the size. I've already told you, right, how to reduce the size is basically the resize operation, right? So let me just resize to 500 by 500 pixel. Okay, and yeah, see these things, right? So this it is actually detecting as bus, okay, and these are actually the person with the confidence score, okay. So now I hope you will try to get it, that what I'm trying to sell. Again, I'll tell it from the very beginning, okay. What I did is that, first of all, I have already imported this YOLO v11 model, okay. After that, I am actually reading this model, okay. And if you're worried about that, where am I getting all these things? So I am getting it from the Ultralytics repo, okay, in the detect section. Now again, I am printing the result. So this is basically final result, okay. And if we go inside this result, so I will be getting this, all these 5 bounding boxes, okay. The first 2 is basically the center coordinate, and the other 2 is basically the width and the height, correct. Now what I'm supposed to do is that I will be again using the result dot plot, which means that whatever the results that I'm getting, right, so I am going to like plot the image. Now plot is internally, okay, the plot is internally try to do this calculation, okay. So explicitly I don't need to first of all like convert the center and then do the taking the difference, okay, and taking the difference and then like finding out the top left and the bottom right corner, okay. I don't need to do anything, because this function itself is try to do these things. Otherwise, if I would have used the computer vision library, I will show you, then I explicitly needs to try to rescale it, okay, because I was not using this dot plot result dot plot method, okay. So that is why it becomes very easy, right, and then I could able to plot this image, right. Similarly, let me walk you through a very traditional way, right. So yeah, these are actually all the same thing is there, the same thing which I showed you above, right. Now let me just walk you through a very traditional way, that what is like the manual bounding box plotting, okay. So as you have already seen this thing, right, you will be getting the, so from the YOLO detection you will always get the bounding box with the first value as a center x coordinate, the second value as a center y coordinate, the third value is the width of the box, and the fourth is basically the height, okay. Now do we need to rescale it? Of course. So like for example, if you're not like rescaling it, right, rescaling it means what? Rescaling it means like whatever the pixel belonging from 0 to 255, right. So suppose if you wanted to normalize it from 0 to 1, you can actually do that thing, okay. So for now, let's say that I am not rescaling it, I am just wanted to just plot this coordinate, okay, because I already got the very physical coordinates, so I would just wanted to plot this bounding box over it, okay. So now what I'm supposed to do is that instead of like taking the help from result dot plot method, because I already told you that plot method implicitly try to manage everything, try to do rescaling and other thing, right. Now suppose that if I'm not using any plot method, so do I need to rescale it? Of course. That is why here I am rescaling it. See, whatever the bounding box that I got, like total 5 bounding box, right. So it is actually iterating over one by one up to 5 bounding box, right. And for each bounding box, it is like converting this into in order to find out the top left first, like the top left x1 and x2 and the top bottom right, right. So again, the top left, which is x1 and x2, and the bottom right, right, by doing what? By doing this operation, right, center x minus of width by taking the half of the width, and center of y by taking the half of the width. Similarly for the bottom right, you are getting by additioning, like by doing the addition operation by taking the half of the bit. Okay, these things I already told you, right, how to do it. And again, by using the CB2 libraries, I am again plotting the same thing, and if I do, you will get something like this, right? You will get again the same thing. Okay, so either you go like try to use it the Ultralytics YOLO dot plot method, and you can directly able to plot this image, or you can actually like try to use the computer vision like the CV2 libraries. Okay, and then again from the Ultralytics you call it, you take the bounding boxes, and then again you explicitly by yourself rescale it. Okay, instead of using dot result dot plot, you are actually rescaling by yourself, and you will be getting this kind of a detected image. Okay, so this is basically the object detection on, let's say, on set of one single image, right?